I'm Anil Kumar, and in this video we will actually prove most of the cofunction identities related with sine alpha. Well, my students are very troubled since they have to remember 12 cofunction identities, and let me tell you that it is not really difficult. Let's try to understand the concept. The question here is, write equivalent trigonometric ratios for sine alpha. So let me first consider the coordinate plane here, and when we say sine alpha, we'll consider a point here which is, let us say, P, coordinate points A and B, and the radius is R. And this angle for us will be alpha. So whenever we are taking an angle, it will be in standard position. So the initial arm will be along positive x-axis. So that is the position of our angle. And now sine alpha in this case is how much? Sine alpha will be, opposite side is b over r. So sine alpha is b over r. Now when we talk about cofunction angle identities, then we are trying to see this related acute angle in different positions. Now let me take one position where angle is in quadrant 2. So if I am in quadrant 2, let us say like this. So same point rotated so that the rotation is in a way that we get to this angle which is alpha. Now in this case the principal angle is pi minus alpha, right? So here we have sine of pi minus alpha, right? So this is pi for us, this is 0 position. Now you will see once you do this counterclockwise rotation, the point A and B will actually become minus A, because x is negative, minus A and B, right? And R will always be positive and will remain as R, correct? Now in this position, what is sine of this angle is pi minus alpha, right? So what is sine of pi minus alpha? Sine of pi minus alpha is b over r, right? So which is same as sine alpha, correct? Because sine alpha is b over r, correct? So which is same as sine alpha. Now let us consider another position, and this time we are going to consider a position which is pi plus alpha. Let us to say this position, right? So in this case our principal angle is pi plus alpha, right? So this is my acute angle alpha. So I'm talking about this angle which is pi plus alpha, right? This angle. Pi is this much and then alpha. Now if I do rotation by pi on alpha, then what do we get? We get to a point where the coordinate points are, the x value is minus b, but minus a and minus a, let me write clearly, and y value becomes minus b. So in this case, what is sine of pi plus alpha? It is going to be the opposite side, which is minus b over r. B over r is sine alpha, so minus b over r will be minus sine alpha. Do you see that? So what we notice is that whenever the rotation is by pi, in that case we come to quadrant 3, and in quadrant 3 sine is negative. So sine pi plus alpha should be minus sine alpha. Do you see that? So that is how you can actually relate it. Now let us look into the rotation by pi by 2. Whenever you do rotation by pi by 2, the coordinate points swap. X value becomes y value becomes x value. So starting from the same point P with coordinate points A and B, if I move to pi by 2 position, let us say this, right? So alpha plus pi by 2. So we have this position as alpha. Now from here this position is alpha plus pi by 2. In that case, the image point P dash will become B and A, but B is along the minus x-axis, so it is going to be negative B. In this case, since the rotation is by pi by 2, sine becomes cosine, cos becomes sine, since the values swap, right? So what is cos of alpha plus pi by 2? Cos is adjacent side, which is minus b over r, right? This is r. Now since you know b over r is sine alpha, I could write this as, let me write here itself, minus sine alpha. Do you see? So when you do a rotation of pi by 2 counterclockwise, then you get the relation that cos of alpha plus pi by 2 is minus sine alpha, right? If you do the rotation where alpha plus 3 pi by 2, right? So this is the angle alpha, and we rotate it so that it comes to this position. That is to say that the rotation is alpha plus 1, 2 and 3 pi by 2. In that case, what happens? In that case, we get a point here. Let me write down the point P double dash as x value is positive. So this value B is positive, but A value is negative. The Y value is negative, right? So in this case, what is cos of alpha plus 3 pi by 2? It is going to be B over R, which is same as sine alpha. Do you see that? So cos of alpha plus 3 pi by 2 is same as sine alpha. Cos of alpha plus pi by 2 is minus sine alpha. Sine alpha is b over r, as we saw, and sine of pi minus alpha is equals to sine alpha. Sine pi plus alpha is equals to minus sine alpha. So that is how we can get so many relations. And in similar fashion, we can explore cos of alpha minus pi by 2 also. If I do alpha minus pi by 2, I come back to the same position, right? So in that case, that should be equals to sine alpha, because that is also, if I go from alpha to minus pi by 2, then this is my position. Is that okay? So in that case, again, it is sine of alpha. Since cosine is positive in quadrant 4, we get a positive sine. Since cosine is negative in quadrant 2, we get the negative sine. So another easy way of looking into it is that if the rotation is by odd multiple of pi by 2, that is to say 2n plus 1 times pi by 2, in that case, depending on whether you are in quadrant 2 or in quadrant 4, cos of alpha plus this value is going to be either minus sine alpha or plus sine alpha. If you are in quadrant 4, it is going to be plus sine alpha. If you are in quadrant 2, it is going to be minus sine alpha. Do you see that? So that is how you can summarize your learnings. But in case we are adding and subtracting pi, so if you subtract pi, then you come back to this position. Do you see that? What I'm trying to say is sine alpha minus pi, if you write, then you come back to this position where sine is negative, and therefore will be minus sine alpha. Do you see that? So that's another way of looking into it, correct? So it really depends on which position we are comparing with. So if we apply the cost rule, it becomes kind of simpler to figure out which sign should come. I hope this helps you to understand cofunction identities. Thank you.